to recording.
No, go ahead. Just on time. Are you staying in here?
Yeah, he wants me to stay in here.
Oh, wow. Okay, everybody, it's 2 o'clock, so we will go ahead and begin the presentation on Legionella detection to diagnostics. We will try and answer any questions more towards the end of the webinar so we can get all the information out and see if we can't answer your questions before we get to the end. We had over 100 registrants for this webinar today, so we can tell that there is a lot of interest in this, and we will do our best to give you guys the best information. Let's go ahead and start. As you can see, today this presentation is presented by me, Rony, and my lab director, Dr. Rajiv Sahay. Just a little introduction on me. I have my bachelor's degree in health sciences from the University of South Florida. I have analyzed several thousand environmental samples in my time working here at Environmental Diagnostics Laboratory. I have expertise in identifying bacteria, fungi, and other indoor air allergens. And I have affiliations with the American Industrial Hygiene Association and the Continental Automated Buildings Association. This is Dr. Rajiv Sahay. He has over 18 years of research and industry experience. He's analyzed over 125,000 environmental samples. As you can see, he has a number of affiliations. He served as board member on the American Industrial Hygiene Association. He has expertise in many more things than I do: aerobiology, bacteriology, mycology, immunochemistry, industrial hygiene, public health, and he's also provided expert testimony in the past. Today, this is a breakdown of what we're going to cover in regards to Legionella when it comes to detecting it, to diagnosing it in buildings, and to take care of it when it is there. We're going to have an introduction on what Legionella is, methods of detection, methods of diagnostics, how to manage and regulate buildings in regards to Legionella, and we're going to go over a few guidelines and standards in terms of Legionella, which also includes the new ASHRAE standard that has been recently updated. Now, Dr. Sahay, do you want to go over a little bit of the history of Legionella?
Yeah, sure. Good afternoon to all our viewers, and I welcome you in this presentation. Today's presentation is very important with ongoing Legionella issues. Many of you are aware that recently in New York there is a case where we have Legionella outbreak, and we are still managing that outbreak. But before we go there, I just wanted to give you some stats that approximately 124 people were come under this Legionella, and then out of 124, about 94 were treated for the Legionnaires disease, and sadly 12 were just not survived. So that was the intensity of the recent Legionella outbreak in Bronx, New York. But we need to understand what is Legionella. Basically, Legionella is a bacteria, and first time people come to know about this bacteria when mysteriously in 1976 during the American Legion convention in Philadelphia, a number of people, to be accurate, 182 people or so, were infected with this mysterious bacteria, and with the help of CDC, finally Dr. Joseph D. McDade come up the identification of this bacteria, which we know as Legionella. Basically, Legionella belongs to gram-negative category of bacteria, and it can be isolated both from the environment as well as from the clinical specimens. The bacteria appears Coccobacilli in shape under the microscope, and currently we are aware of about 50 different species of bacteria. So Ronnie, you know that the total number of species is getting bigger and bigger each day and every day. And I just wanted to also give you some number that how important it is to study this bacteria, Ronnie, that about 8,000 to 18,000 cases of Legionnaires disease each year is being reported in the United States. 10% of them are fatal. That's very, very important. And then about 90% cases are not diagnosed, meaning it is not reported, it is not coming. So you can understand that how important it is. We have also studied the Legionella, how it is being acquired, where people can get Legionella. But just to give you a prospect, about 23% of the Legionnaires disease is basically hospital acquired. Well, 77% of these things are non-hospital acquired. So that tells you the importance of this bacteria. Many times this bacteria is travel associated, especially in Europe. About 20% cases are linked with the travel. So that tells you the intensity of this bacteria. About 20 to 10% death is still infected people dies. So that tells a lot of a story, Ronnie, on this particular subject matter. So, well, we have to be also very careful when we start discussing about the Legionella. Very first question, many a time I asked myself that what is the best place to detect Legionella? Well, before we answer that question, let me tell you that the Legionella can be clinical, or it obviously ubiquitously in the environment. So the clinical infestation of Legionella is in terms of disease such as Pontiac fever, and you can see on the monitor that this is the symptom, an acute self-limiting illness, flu-like symptom. And the other one is the Legionnaires disease, which is pneumonia-like symptom. And the third category of the clinical infestation is the pulmonary infection. So upper respiratory tract, so the symptoms, so you can see that one.
Now, Dr. Sahay, it's the term for both Legionnaire's disease and Pontiac fever is legionellosis, correct?
Yes, because both of them initiated with the bacteria Legionella. Now, Ronnie, how to detect the clinical Legionella? So you know that the very best way to isolate the Legionella from the clinical situation is the urine or respiratory secretion by performing the culture. So where you get the high risk in this field, Ronnie?
Typically for Legionella detection within someone, there's a higher health risk groups. The first one of those groups is immunocompromised individuals. They don't have an immune system strong enough in order to defend themselves if they become infected with the Legionella bacteria. The next group is anyone above the age group of 50 years or more. That's typically also kind of considered an immunocompromised group in a sense, because as you get older, your immune system does begin to decrease in function. And unfortunately, that is the case. And so the older you are, the higher of a chance you might be exposed to Legionella and become infected with it. The next risk is a community outbreak. Typically, if Legionella is found or detected, it is within a manner that can infect more than one individual, as we were talking about earlier in New York in the hospitals. That kind of can be considered a community outbreak because it is within a, that idea of a community, that the method of Legionella transfer to those individuals can happen to more than one person. Individuals with a smoking habit, that can be caused because Legionella is airborne. Once it's aerosolized, if someone's breathing it in, that is the mode of transmission. People who smoke are going to have weaker lungs. They're going to have breathing problems, and so they're more susceptible when it comes to Legionella infection. And then that also leads into people suffering from lung disease, COPD, emphysema, etc. It's also tied in with the whole lungs, breathing it in and being infected with it. Now, when it comes to the sources of Legionella, Dr. Sahay, what can we expect? Where can we find these sorts of things?
As I said you that environment, mostly the source of Legionella come in form of outbreaks, individuals, symbiotic relation. This bacteria grow in the water kind of environment. Many times these bacteria are growing in the biofilm kind of situation where there is a sedimentation and the bacteria flourish in that biofilm. So the important thing in the environment about the environmental exposure risk for this bacteria. So the risk is associated with the contaminated water, soil contamination, and aerosolized form of the bacteria when you have the mixture and things like that. We will be discussing on those things little later in this presentation. That is very important to understand that the Legionella can also be transmitted in form of aerosol through air. So if you are trying to detect the Legionella bacteria, you have to be focusing on three main components. The first one is the source itself, where the source of the bacteria is. The second component is the growth factor, that obviously if you have a good growth factor, good growth condition, the bacteria flourish in a good manner, and then it get disseminated through the environment or through the air. And then the third thing is that what kind of sampling or what kind of sample is good for monitoring this bacteria. So these are the three major point in order to detect the Legionella. So about the source. The source can be natural environment itself, or it is an artificial environment. Natural environment, mostly like an aquatic kind of situation, such as pond, lake, groundwater, seawater, etc. And the terrestrial environment, such as soil or contaminated soil, and the biofilms. And again, we will be discussing the biofilm little later in this presentation. The artificial environment is the one which we need to be careful, because this is the human design, and how the building is designed, it has to do a lot with that. And we will be discussing about the artificial environment precisely during this presentation a little later. But basically the potable water and distribution system is one of the major source where this bacteria can flourish. The cooling tower and evaporated condensers, those are the site of bacteria. Swimming pool, spa, hot tubs, HVAC, heating, ventilation, air conditioning system, healthcare facility, hotels and safe, water parks and fountains, and other environmental source. Those are the potential places where this bacteria can grow. Now, I wanted to give you a photographic, an idea that how you can, narrow down the source. For an example, in the water faucet, which is very, very common in a dwelling place or in the industrial or residential setup, those are the main place where biofilm can be formed, such as shower head, AHU, drain pan, humidifier, etc. Those are really the place look for, and where the Legionella can flourish. Now, the outside environment, basically the pond and the cooling tower, these are the two major sources identified for the growth of bacteria, Rony.
So it looks like Legionella won't let anybody have any fun, huh?
Yeah. So, the important thing, Rony, is that the growth factor, what are the supporting factor which help to propagate this bacteria?
Well, as we have listed here, typically, this can also apply to more than Legionella as a bacteria, but for bacteria specifically, they have an optimal range of 32 to 42 degrees Celsius. Typically when people test for Legionella, they go ahead and test hot water as well as the cold water, and part of the reason for that hot water testing is because Legionella can thrive in those temperatures. A pH of 2.7 to 8.5, Legionella can survive in. Once again, typically we're dealing with water. Water has a pH of 7 as long as everything's okay. The optimum pH for Legionella is 5 to 8.5 for a little bit more, for better growth essentially for Legionella. And sort of nutrients that they require, anything organic, so any sort of, let's say, somebody's taking showers or anything like that, they're rubbing off all the dead skin, all the grime and dirt and everything like that. Other bacteria, a number of different organic things within the water can be a source of nutrition for Legionella, and biofilms help Legionella stay in one place when they find a good source of food or a place that food comes easily to them. Biofilms will help them stick into a certain area and propagate and keep growing.
Yeah, other day one person was asking me about the organic constituents, and that's very important. That's why I'm bringing this in the picture. That the Legionella, you will be totally surprised that sometime if you have the heterotrophic bacteria is flourishing in a water, then chances of getting Legionella is more, because as you indicated that this particular bacteria require rich organic constituents, which is indicative of the other bacteria growing and thriving. So the organic constituents as nutrition for the bacteria basically support them for the growth, and that what happen in case of Legionella as well. Now, question arises that how to sample the specimen for the Legionella bacteria. The very first thing where I want to put emphasis that a good sampling is a good method by which we can analyze Legionella in a nice way. If sample is good, the chances of investigation or the laboratory practices are superior. So first, it is very important to make a good strategy that how, where, when, how much, etc. sample need to be collected. For focusing on those aspects, we have to do the thorough environmental investigation, engineering proportion of the building, that what is the total engineering behind the building, whether this whole exercise has been taken as a proactive measure or a reactive measure, that also matter, so that you can identify your potential places where you can collect the specimen. And then don't forget, it is very, very important to have a good strategy for sample transportation, because the sample transportation is the way you can preserve the sample before it come to the laboratory. And nevertheless, system surveillance, that where you are collecting bacteria or the Legionella sample, which actually working out or not, that is also a very important aspect of the whole strategy. So sample strategy is the best part, I believe, that if you are trying to explore and diagnose the Legionella in an environment. Right, Rony?
Yes, sir.
So can you go ahead and give our viewer at a glance view that what kind of sample one can collect for testing the Legionella, especially when we are talking about from the laboratory point of view?
There's a few different methods, and all of them can have their advantages and disadvantages. The first one is a water sample, just whether it be 250 milliliters or a liter of water, that can be used to go ahead and test for Legionella. Another method used is a swab sample. Let's say somebody was worried about a shower head or something along those lines. A swab used along a shower head or a fountain or something else can be used to detect Legionella as well. A biofilm sample is something along those lines, where if a biofilm is detected or if it's visible, one can go ahead and collect it in a different, a number of ways, whether it be with a gauze, a swab, or some other method that can be used to collect Legionella as a whole. And then also finally, air sample can be taken in order to detect Legionella, as I was stating earlier, that typically with Legionella it is aerosolized as a mode of transmission.
Well, that's very well, but can you go ahead and elaborate, how much water one should collect for testing the Legionella and how they should be collecting those water samples?
Of course, and this is important. Water is drawn from the surface of the source, or it could be, you want to try for the most part to avoid any other debris, something like mud or dirt or anything along those lines that could get in and affect the sample. You typically want just water when it comes to collecting the Legionella. You want to collect 1 liter of water for most potable water sources. A smaller volume of sample may be collected from cooling towers or non-potable sources. That can be more helpful if, say, somebody has over 100 samples they want tested or something along those lines, or if the Legionella or any Legionella is suspected to be in higher quantities within that source. A large sample, as we have here, 1 to 10 liters, is needed for detecting Legionella in low concentrations, such as municipal water. Something like municipal water, it's a bit more important whether or not there's Legionella in it at different ranges. So that is why, if there is any in there, you want to collect a larger sample so that it is collected and can be tested for. And also, when it comes to any water that may be treated, a 0.5 milliliters of 0.1 N sodium thiosulfate for each 1 liter sample can be used to disinfect, to neutralize the disinfectant used in water that is treated, typically for use against Legionella. We're going to go ahead now and go and talk about the swab samples. Now, with swab samples, like I was stating, if someone wants to test a shower head or something along the lines, such as a fountain or something, you just use a swab, you run it along the faucet or a shower head or anything along those lines, and that can be used to test for Legionella as well. The swab can also be used in water itself from the source. As you can see here, it could be collected from the source surface or from submerged surface, and that can be used as well if a larger sample can't be collected. And we also have, like I was saying earlier, biofilm samples. There's multiple ways that you can collect it if it is noted and you want to test specifically for Legionella. You can collect it as a bulk sample, you can collect it with a swab, or you can collect it with a wipe or gauze. As long as it's there and you can collect it and send it in a appropriate manner, it can be tested for. If Legionella is present in there, it can be observed. And the last one that we want to talk about is air samples. I was stating earlier that there are certain advantages and disadvantages to all the sample collection methods. Hopefully I was kind of going over it and it was a little bit more obvious, but if not, especially with air samples, they can be found, or they can be used to collect Legionella, like I stated earlier, because it is aerosolized and it is put in the air and that's how it's transmitted. However, it is more difficult in that sense to collect it. However, if this method is used, an all glass impinger can be used, an Anderson sampler can be used with a selective media or non-selective media. Typically you want to use selective media when it comes to Legionella, because it will help to inhibit other bacteria. It will help to find the Legionella or to detect it without interference from other bacteria. And when you do an air sample, you do want to run it for about 10-15 minutes at about 28 liters per minute. That will help to try and get a better reading when it comes to detecting the Legionella.
Yeah, and the reason behind that, collecting a little more air sample is that, as you have said earlier, that this bacteria comes in air in form of aerosolization. So the bacteria doesn't come like in a independently, like, from the source. Rather, whenever the natural fountain or the artificial fountain having a splash of water, then it comes in terms of, like, water droplets, and that finally aerosolize. Or sometimes people use mister and stuff in a summer season. So if the contaminated water is being used, then that can also be mystified, and then that finally aerosolize. So you may want to, like, collect the sample for a little longer than typically collected for other bacteria.
That was good notes to add to that, Dr. Sahay. Thank you. We are now going to talk about the sample storage and transportation. This is a very crucial matter when it comes to sending in Legionella samples. Some people might think it's as simple as just collecting it, sending it in through the United States Postal Service, and just having the laboratory receive it. Unfortunately, it can't be that easy. Of course, we need to make sure that when the samples are shipped, that they are kept at a proper temperature. First we want, when we collect the samples, we want proper documentation, such as the chain of custody. We want to make sure that if there is Legionella, you know where that Legionella source is coming from where you collected the sample, so that it can be remediated, it can be fixed at the source, rather than everyone saying, oh, there's Legionella within this entire hospital, but we don't know exactly where it's at. This will help in clarifying that and in saving time and money. Next thing you want to be careful about is the room temperature. You want to make sure that Legionella, when it is collected, that once it is collected, it has to be kept at a temperature that won't let other bacteria continue to grow or inhibit the Legionella in there. If Legionella samples are shipped without proper care about how they're shipped, other bacteria can grow faster. Let's say you're sending it just in regular mail or something like that, and it comes through and it's being exposed to the outside temperatures, it's heating up, it's letting the other bacteria grow. It's going to skew the Legionella count. It might inhibit the Legionella, so that when the samples are observed, there is no Legionella, even though there was Legionella in the sample originally. You want to protect the samples from light. Once again, that can affect how the other organisms within a sample can grow and interact with each other. And once they are transported, once again, you want to make sure that the temperature is appropriate for Legionella, and that it is going to sort of be the best sample once it arrives at the laboratory.
And good sample is always valuable for the diagnostics, right?
Of course. Now that we talked about how, a little bit on how to collect the samples and how to ship them and everything, we're going to go ahead and talk about how the laboratory goes ahead and deals with those samples once they're received. Dr. Sahay, would you like to go over some of the methods in the lab?
Sure. In the laboratory, the main goal is to identify the Legionella bacteria itself in the submitted material. And when I say material, meaning that the environmental sample, which mainly come from either air, liquid, which is water, or surface. So what happened in the laboratory, that there are a number of technology or techniques is known to isolate and detect Legionella. I just wanted to touch some of the important technology which is nowadays used, and for convenience I have categorized all these three major category or technique by which Legionella can be identified. The very first one is non-culture method. In this particular method, actually we use a dye, and with the help of a dye is a fluorescent antibody which fluorescent under the microscope, and that's how you identify the bacteria, because it has a great capacity of fluorescing under certain condition, and that's what we take advantage of, and that's how we identify this particular bacteria without even culturing it. Now, there are a number of other tests which is based on the antigen identification, because if you have the antigen of that Legionella bacteria, antibody antigen reaction can kind of give you some indication or sometime conclusively identify that the bacteria belongs from certain species or genus. And those technique mostly people use for the rapid testing, because it doesn't take a long incubation period. It doesn't need to grow the culture. Rather, this particular reaction can be from few minutes to few hours, and as a result of that, you can get the identification. But the culture method is always a gold method or gold standard for isolating and identifying the Legionella, and CDC actually recommend the culture method is a gold method. So this culture method help us in the recovering of bacteria, because you have the matrix and you plate them on the media plate, and then you see the growth after certain incubation period. Typically it more than 5 days, you will be start seeing the colony growing. In laboratory, it could be more or it could be less, depending upon the other situation and other parameters. But the growth media typically use BCYE, buffered charcoal yeast agar extract. That is a very good media to support the isolation of Legionella from the material itself, meaning the water or sample itself. The agglutination test is the way to go if you are having the colony growing, and if you have a presumptive identification on the bacteria, then the agglutination test is the good way to ascertain that this bacteria belong to the Legionella. And then the result by this method, that is a limitation of this particular technique, is that takes a little longer, maybe you're looking at 10 to 12 days to complete the entire process before you make an identification. The other thing is molecular based technique, that what I'm referring here as a DNA amplification, and many of you are aware that we are start using more and more polymerase chain reaction. It is a DNA nucleic acid based method in which you polymerize the particular DNA of an individual organism. Depend upon the prime and probe, you identify that particular organism. That is very important, and the great advantage of this method is that it's less time consuming, and result can be achieved within few hours. But at the same time, the biggest limitation of this particular method is the validation. Still, we have to do a lot of validation that actually this method works. So in non-culture method, I have given you a kind of a snapshot in my previous slide, but non-culture method, the very important thing is the isolation of bacteria. So the isolation of bacteria often initiated with the filtration. You get the material in filter, and then you take the dye, and then you kind of put the dye stain in terms of a stain, and then you look in the under the microscope, and then you make the assumption that what bacteria. On this particular slide, you can see that the fluorescing area, which is indicative of a positive staining, positive test, and that it means that the Legionella is present in that. Now in the culture method, as I was telling you, that on this particular slide you see literally a culture plate having Legionella colony on it. In this method also, as I said you, that the first bacteria need to be recovered. Either we use the filtration method. There are a couple other methods, enrichment method. Sometimes people enrich it by centrifugation, and that is plated on the media, and that how the colony is being isolated. The plating is basically either direct plating or filtered plating. Sometimes people treat with the acid. So other organism which is not the target organism is not going to survive in the acidic environment, and only the Legionella is going to survive. So you will be end up getting the colony of Legionella if there is any Legionella in that particular sample. Afterward, you evaluate very critically the obtained culture, and that's how you make your presumptive identification about the Legionella. Now, let me go and give you a little bit more information about the PCR method, which is the DNA amplification method. The DNA amplification basically, again, recovery of bacteria and then amplification of DNA by PCR method, and then you look for a specific target, and that's how you identify the bacteria. As I said in the very beginning, that the validation of this method is still in question, and I'm pretty sure in coming days a number of workers are working on that, and we can have a very good identification by this method. The advantage of this method is that it is less time consuming. Now, about the diagnostics from the laboratory point of view, Rony, what happened that if you are looking to diagnose, and this is very important, I want to take some time to explain that if you are directly or indirectly involved with the diagnostics of Legionella, make sure that these 3 points should be very carefully crafted and very carefully practiced. The very first thing is always good idea to do a physical survey. When I say physical survey, meaning that you are going around that particular building and you are making sure that how the water system is being laid out in that building, and that is very important. I will discuss that a little later. Then you should also keep in your head that you are investigating or exploring or taking the Legionella test due to the clinical concern, or basically it is something the environmental in nature. The other point which you may want to consider is that whether it is the indoor activity where you are suspecting Legionella, or it is the outdoor site where you have the Legionella. So these are the 3 main point which you should be concentrating in order to diagnose or give a proper diagnostic to a Legionella scenario. Now, the environmental, like physical and environmental, this all helps to indicate that where the problem lies and how we are going to obtain the sample, how we are going to identify it so that we can manage it in an appropriate manner. So environmental assessment, and again I'm not going to elaborate every point because it will be taking long hour today. Unfortunately the time is only 1 hour, but maybe in some other presentation I will be definitely giving a very detailed account of that. But for this purpose, the environmental assessment, environmental exposure and evidence of disease and outbreak, that is very important, and one should be taking count of that, document that, and go and explore these particular method so that you can get some very fruitful outcome and you manage Legionella in a way it's supposed to. Now, the environmental assessment, basically the surface water, as this particular bacteria loves water, and I haven't heard case or episode of marine water. So there is another important point I want to elaborate here, that mostly this bacteria, and I'm almost positive over good amount of time this bacteria can be reported from the fresh water. That can be either in terms of potable or non-potable water if you are looking in terms of building water. And then the other very important place where this bacteria can grow is the HVAC or chiller system. Many times if you have a very big HVAC or chiller system, the water is continuously drifting through that, and you have a very bottom layer which start mudding, or all the garbage kind of start settling there. So that is the another layer, and then on top of those things the water is always there. One more important point I want to draw your attention, that thermally polluted lakes and streams are a safe haven or harbor for the Legionella bacteria, because as Rony has indicated earlier, that this bacteria is thermotolerance. It can go to 40 degree, 45 degrees Celsius, and if I have not mistaken that some author has even reported this bacteria up to 65, 66 degrees Celsius. So this is pretty high temperature. Now, in the Indoors, you basically look for all these which is listed here, like taps, shower, valves, eye washes, safety shower, pipe work, material, evaporative coil, etc., or humidifier. These are the main source which you should be concentrating and you should be targeting to collect sample from here. So far the outdoor side is concerned, it's like ornamental fountains, whirlpools, and other water sources within and near the facility, such as lake, pond, water bodies, etc. So what basically you're looking for the building size, first you have to be making sure that you need to understand the structural and the the total engineering of the building, so that you can have a very good idea that how the water system is working within a building or around a building. Then you have to identify the potential source of water, whether it is a municipal water or groundwater, or how the water is being supplied to building. A periodical inspection or storage tank, water treatment system and pumps are also very important. Location of water heaters and boilers are also very important, because that can be the place where Legionella may start flourishing. Fittings used in systems such as tape, shower, valves, pipe work material, aerotas, etc. is the another place which you might want to concentrate. And then the water route inspection is the gist of all the practices which I have said to you. Now, the information about the procurement from the occupant is very important, because the information can lead you the significant clue by the occupants, so that you can concentrate more on those areas where you may suspect a problem. Routine maintenance of building is very, very important. Anyway, it should be maintained in a nice manner to avoid lot of problem. GFP good practices approach are really encouraged in the building. And the potential environmental source, as I said you that if you have a good idea about the building structure, the information from the occupant, then you can easily target your the potential area where you can go after and collect the sample and identify whether the problem exists or not. The suspects in the clinical specimen by the near hospital or any other healthcare facility around near area is a good place where you can get the suspect which visit those hospital. You get information and you can just make a surveillance and you see that whether the bacteria is actually existing there or not. And please document all the evidence, especially when the disease and outbreak kind of scenario happen, because that helps a lot. Then it is time to discuss about the management and regulation, and this is a very important aspect of our presentation, because we promise our viewer that we are going to give a good snapshot of the ASHRAE standard 188.
Yeah, and because this is so new and a lot of research and public opinion has been put into it, I think people are very interested in this, and it's part of the reason why we're going over it. We're going to go over this standard a little bit more in depth than the other ones. There are a couple other ones, such as one by OSHA and another one. However, this one I believe is going to be more widely used. The first thing that is going to be talked about when it comes to it is HACCP, which we're going to go over in just a moment. The microbiology that the ASHRAE standard talks about, how that should be performed, monitoring, aerosolization, disinfection, and maintenance. All these are contained within this standard that's new, and it's a good read if you have a chance to get to it or purchase it, or however you can obtain it. It's very good to read, because this will be a good standard, and I believe in our laboratory it's what we're going to refer to at times as well.
So at this point, I want to elaborate on the hazard analysis and the critical checkpoint, and this is very, very important. First, I'm not sure how many of our viewer is aware of the ASHRAE 188. Basically, ASHRAE 188 give information that how you should be responding or managing the water system, so that first of all you prevent or control any risk associated with this bacteria. So truly it tells you the good practices in a way, in a sense, that what you should be doing in order to avoid the problem. That was a little introductory remarks about that. The second thing which I must project here is that this particular guideline or the information is not applicable for the single residence or for the residential environment, except a few. Rather, this is being designed by doing a lot of research with multi-family buildings, high-rise condos, like building 10 stories more, the hospital, healthcare facility. These are the type of building which was taken under consideration, and then this information is being developed for the building managers or whosoever maintain those buildings, so that they can manage the water system or manage the whole environment in such a way that they can avoid the Legionella. So in order to do that, it's very important that you should have a CPM, which is critical path management, that you develop your goal, you make your team, that this team is going to look after this and this team is going to look after this, when to sample need to be collected, how to be collected, where it need to be sent, if it need to be sent for the laboratory analysis, etc. So these are few schedules which can be made with the help of CPM. Now the hazard analysis. This is a very, very important component of it, and again I'm not going in a whole lot of detail, but the hazard analysis is the analysis which is again performed to understand that where most of the risk is associated. Then you analyze the critical control point. What are the points you need to be targeting or focusing most from where this problem can be initiated or can started. And then the critical limit, you have to be also focusing on that, targeting on that. Very important aspect is that you should be continuously monitoring the whole system, that the water system in a building should be very periodically monitored, like when it is shut off, when the maintenance is performed, when the water is being cleaned up, when the pipes are being cleaned up. These things should be monitored very, very, very closely. Now if you have some problem, then obviously you respond to them with the help of a corrective action. But if you do not have a problem, then still you can make your CPM in a way that it will initiate and preventive action, so that you should not be dealing with this problem. The verification of your task is very, very important, that whatever you are doing is verified. It will be what you call validation. It should be validated, that what the ASRE 188 talks about, so that you can avoid. And then very important thing, ASRE encourage everybody to document. So record maintenance is a very big part of the whole equation. So record maintenance typically is a good part, and our laboratory has developed a protocol, and we provide a sort of SOP or a scope of work, so that you can keep your record maintained and how to initiate the whole process and how you should be going about that. This is being given in detail. Should you need a copy, you should be contacting us. We'll provide you that. Then the microbiology, according to the ASRE, is one of the very important aspect, and they have touched upon that. Actually, there is a whole paragraph in the ASRE standard 188 which describe about the microbiology, and the main focus of the microbiology is to understand the various bacterial flora, which we call the microbiological flora in the water, and there should be in accordance with the local or other regulation if it is in place. If it is not in place, then ASRE simply encourage to make sure that the heterotrophic count of bacteria in those water should be less than 200 colony forming unit. It is also important microbiologically to understand the transmission of the bacteria, that how this bacteria get transmitted. One thing I want to make sure our viewers will encourage and tell people that it is not, again I repeat, it is not going to transmit it from a infected people to the other healthy people. So there is no evidence of man to man or human to human transmission. Rather, one can get sensitized by inhaling the contaminated aerosols, which, as I said you earlier, come in terms of mist, and finally it is in air as a water droplet. So if you are in contact with that, you might be a victim of that, but you are not going to acquire this disease from any other person who is having or acquired this particular Legionnaire or Legionella disease. The pathogenicity of the bacteria is very, very important because as we have mentioned in our presentation that there is over 50 different species of bacteria is known, but not all the bacteria necessarily is going to cause the Legionella. Especially one species come in my head, Legionella pneumophila, and again in that group there is several serotype, and some of the serotype is more dangerous than other. So it is not fair to say that all the Legionella bacteria is going to be disease causing and having the pathogenic significance in it, but some of them are, yes, truly pathogenic bacteria, so we should be paying attention to that. The other point which I want to describe or discuss here is the economical impact. It has a vast economical impact. Mostly you see what happened in the Newark area. Then once people start thinking, oh, Legionella outbreak is there, then it gives a big economical impact because people start avoiding those places. So very first place hotel and other places where people stay is going to be empty. So that is going to create some impact on our economy, and that's why we need to consider that one, people death, because sometime this bacteria when you acquire, then it is going to be no recovery, so you are going to be dead. So basically what we need to do, we have to be taking some approach, such as preventive approach is the best approach, and I really encourage everybody to just obtain a copy of ASRE 188, where very good description is given. Many times people say it's very complicated, but yes, I understand that some very scientifically driven words are there in that description or in that booklet, but if you get at a glance view or at a dirty view, you will find out that document is very helpful. So it is being exactly explained, because our presentation is not a long presentation. Otherwise I love to describe point by point, but all I want to tell you at this point, please get a copy of that and follow that, and it is really helpful and it guide you. Sometimes it is being misunderstood that it is in a standard, they are talking about a number or something like that. It's not a restrictive number or a guideline, but rather it gives you a way how you maintain it. So in a reactive approach is also you can derive some information from that ASRE 188, how to address them. The contamination control is also initiated based on those information, and the Legionnaires cases from the local health department in collaboration with that, you can understand what is more important in order to prevent those diseases in that particular area. Now the aerosolization part, I just want to really touch on that one without going any further detail, that the source identification again is a very important one, such as air cooler, humidifier, air washer, mister, aerotas are some very important source inside the building which can aerosolize this bacteria. The mechanism of aerosolization is real simple. It comes in form of droplet, as in a water, a splash, or in terms of misting of the water, etc. And then the transmitter control can only be in place once we know the source and the aerosolization mechanism. Then the transmission can be controlled, because we can control those critical points. Rony, you want to tell our viewer a little bit on the disinfection side, that how they are going to disinfect once they have that problem? So selection of the disinfectants is the main thing because once you know that what kind of method one should take so that it get disinfected. Nowadays everybody is going after the green technology, and I support that because there are several methods by which you can disinfect. The first method is the people use chemicals such as chlorine etc. to disinfect. Then there is a heat method. The heat shock method is that you rise the temperature for certain hour, and the bacteria doesn't survive on those temperatures, so actually the bacteria is going to be killed. The application of disinfectant, if you are using the chemical disinfectant, should be very, very controlled, should be followed as per the manufacturer recommendation, and every possible step should be taken to avoid any further environmental damage due to the use of those disinfectant. And the efficacy of the disinfectant is always be good idea to monitor that whether you did the heat treatment or you do the chemical treatment, whether it work or not. Sometime a situation come when you have to do the emergency disinfectant. Again, it should be perform as per the guideline made by the manufacturer of those disinfecting technique, either chemical or physical, but that should be immediately put in place when a emergency arises. When I say emergency, meaning that when you have a proven case, you have a proven source of bacteria, for sure that particular hotel or tower or whatever is contaminated this bacteria, then the disinfectant should be immediately taken and it should be addressed in that way. Now, the maintenance of this particular issue is of two aspects. As I was telling you, one is the preventive action, the other one is the corrective action. The preventive action help us to prevent or manage the bacteria without having any trouble. If you practice that thing, then chances of getting those bacteria is getting very, very less. For an example, regular maintenance of the plumbing system, routine checkup of the water source, avoid the stagnancy of water, and water temperature monitoring, because as I said you earlier that the water temperature is a crucial factor for the growth of Legionella. Now, the corrective action is the action which you initiate once you have a known case, and actually that can be done very, very carefully. First of all, if you have an idea, you identify that what are the source and where this bacteria is coming, then in that situation, please replace and discard all the Legionella infected equipment as biohazard waste. Again, never throw it without demarking or without uniquely identifying that those are biohazard or bio waste, and then it should be disposed as per the local, state or federal mandate. And then treat the infected water with the disinfectant, as I explained you that it is chemical as well as the physical disinfectant. At this time, I would like to request Rony to go ahead and give our viewer the different standards and the guideline available in order to monitor this bacteria in the building water system.
And I do just want to apologize ahead of hand. I am going to kind of go through this part quickly. We will provide the slides that will have all this information on it after the presentation, so that if you need to, you can review this. These are the OSHA guidelines that we're going to go over. As you can see here, for detection of Legionella within these different settings, whether the cooling tower, potable water, or humidifiers, we have actions levels depending on how many colony forming units, which is what CFU stands for, is detected within those samples. Then that first action level, if any Legionella is detected at that, it's just cleaning followed by biocide treatment of the system if appropriate. Action 2 is taken if there's a higher number of Legionella detected, and what needs to happen is cleaning and or biocide treatment, and immediate steps need to be taken to prevent employee exposure. OSHA clearance testing guidelines say to test domestic hot water systems based on this schedule should Legionella be detected, and this is to assure that recontamination does not occur. It's to be performed weekly for the first month after resumption of operation, every 2 weeks for the next 2 months, and then monthly for the next 3 months. And that last step isn't a bad idea to continue when you want to try and perform preventative maintenance when it comes to following the OSHA guideline. This one is by the HSE, the guidelines. These are for cooling water systems. If you have 10,000 or less colony forming units, that's considered acceptable. More than 10,000, but up to 100,000, we got to review program operation. This needs to have resampling performed just to make sure that Legionella was detected properly. If that is the case, then control measures and a risk assessment needs to be performed. And if there's more than 100,000, then corrective action needs to be implemented and further steps need to be taken. These steps are for colony forming units within cooling towers. As you can see here, there's level A, B, C, and D. Depending on which one, you either want to increase the biocide and review a program, disinfect and clean within 30 days, or disinfect and clean within 7 days. ELAB has an LCPM, which is Legionella Contamination Prevention Management. We've helped, as you can see here, a number of different agencies and organizations in regards to Legionella. We're more than happy to talk about this stuff with anybody to give information, to help set up plans and things like that. So if you're part of this or you're interested and you want to talk with us, we can always have a discussion on it. And now I notice that we do have a lot of questions, and so we're going to take a few minutes to try and take care of all those and hopefully answer these questions for everybody. First one is there specific PPE you would recommend wearing when conducting water samples from cooling towers?
Yes, it is always a good idea to have the PPE, and at least a minimum you should have gloves on your hand, and then a safety glass, and especially when you are under the known Legionella condition, then it is always good idea to have a tie-back suit on so that you can prevent the exposure to yourself. So yes, PPE can be used, and it is a good idea to have it.
All right. We were talking about impingers earlier, so a question was asked whether it's the small industrial hygiene ones or the large air pollution ones, and whether or not those should be run for 10 to 15 minutes, or whether the Anderson sampling pump should be run.
Anderson pump is going to give a better idea, but impringer is not a bad idea either, but it should be the small industrial impringer, and depending upon the media that the bacteria can be isolated, but I would highly encourage to use the Anderson sample because those are more standardized.
Okay. Next question that was asked was, what is the ambient temperature for transportation? Is there a range?
Yes, the ambient temperature it should not be too cold or too hot. When I say too cold, that the temperature should not be dropping down less than 8 degrees Celsius or something like that under the freezing condition. It should not be transported. And then too hot, meaning that the temperature should not be 40-50 degrees centigrade. So as long as it is on the room temperature that considered ideal, which is 25 degrees Celsius, but a little less or a little more is okay, as long as it is transported to the laboratory within 24 to 48 hours, or sometime up to 72 hours as per the CDC.
Okay. Someone's asking about a price list for sampling media analysis. I'm actually going to put up on the screen right now the contact information for the different departments of our company. Here they are. Depending on whether you're looking for pricing or whether you're looking for information on testing or things like that, we do have the different departments here up here at Control Services. If you just call in, we'll find the right person who can get you the correct information.
Rony, we are almost out of time, but still I can entertain a couple of questions if you have.
Okay. The next one we have is that I noticed this as well. There was a certain point where it said ecological impact. However, Dr. Sahay was talking about economic impact. They are both important. The economic impact he had already gone over, but the ecological impact should be explained a little bit more.
Okay, the ecological impact is that, as I was telling you, the very first one is that this bacteria can be in the symbiotic relation with the other bacteria. So many times what happens, the other bacteria, which is good bacteria and good for the ecological system, to maintain the ecological system, can be affected by this particular bacteria, and the gene pool as a total is going to be affected with this bacteria, which is not a good thing, because it is in terms of maintaining, because ecology want or demand the balance. Nature should be balanced. So on microbiological level, it is going to have that kind of impact. Any other question you have, Ronnie?
Yes. Someone is asking about how frequently sources should be sampled.
As you had one slide, Ronnie, that where it is being recommended that you can check first time weekly, and after 2-week interval, and afterward monthly, and then obviously biannual or annual monitoring is encouraged in order to keep tab on this bacteria and this problem.
Okay. And looks like a final question that we have is respirator use. Is respirator use recommended when collecting samples from cooling towers?
Yes, certainly, especially when the known condition or the suspicion of the bacteria arises, then it is always a good idea to have a respirator, because as I was explaining, that this bacteria can also be transmitted in terms of aerosol droplets.
Okay. And then we just have someone stating that Legionnaires has been found in plant mulch materials, packaged and loose.
Yes, it is quite possible, because in my presentation I have indicated that mostly this bacteria is a waterborne bacteria. It resides in water, but the cases in the soil contamination is known, so that quite likely possible that it can be isolated.
All right. And it looks like that's all the questions that we have for now. We will have this presentation and the slides available on the website, pureaircontrols.com. Should you have missed any information, or if you want to review anything, or if you want the material to study it for yourself, and also we have the contact information. So if you have any further questions for us or any of the other departments regarding anything, please feel free to give us a call. And we do hope you enjoyed the presentation, and we hope you guys learned something today.
Thank you very much again, our viewer, because you are the source and a strength, and we always look for the topics and topic of interest. If our viewer has any topic of interest, they might want to send us. We'll consider those topics for our future presentation. Thank you very much, and again, good evening, good night to everybody from the studio of Pure Air Control Services Environmental Diagnostics Laboratory. This is Dr. Sahay and Rony seeing you off. Thank you very much.
Okay, it's muted.
And we're out.